In this video on nuclear fusion, I'm going to talk about the process of nuclear fusion, the formation of stars, the life cycle of stars, and how they are able to sustain their energy output for so long. Nuclear fusion is the joining of two atomic nuclei, that is, the part at the center of any atom, to form a larger nuclei, and therefore a heavier atom. It occurs in the center of stars and is the process by which all energy in the Sun and in any other star is produced. All the energy that we have on Earth originated in our own Sun. Stars form from dust and gas clouds in space being pulled together by gravity. Smaller masses formed by this same process become planets, such as we're familiar with in our own solar system. A protostar is the name for the mass that forms at the center of this dust cloud. It is the earliest stage in the life cycle of a star and can last for up to 10 million years. Main sequence stars form next. These are stars that are fusing hydrogen atoms to form helium atoms in their cores. Most of the stars in the universe are main sequence stars. The Sun is a main sequence star. These stars can range from about a tenth of the mass of the Sun up to 200 times as massive. Red giants then form when small to intermediate sized main sequence stars begin to run out of hydrogen to use as fuel. Because of this lack of fuel, the energy level is unable to be maintained. Therefore, the temperature drops and so does the pressure, causing the star to massively expand. White dwarfs are what remain from the core of red giants. As fusion is no longer being undergone, they release very little energy compared to the other phases of the star's life cycle. The only energy they release is from stored thermal energy. White dwarfs are very dense, having a mass near to that of the Sun, and yet a volume very close to that of the Earth. When a white dwarf has lost all its residual thermal energy, it becomes a black dwarf, the final stage in a star's life cycle. You can see here what I have just described, the life cycle of a star with a mass near to or less than our own Sun. However, the cycle is slightly different for stars that have a larger mass than our own. After the hydrogen in a star's core has fused, stars with more than about 10 solar masses become red supergiants rather than just red giants. These stars have very cool surface temperatures and enormous sizes. They're the largest stars in the universe in terms of volume, although they are not the most massive. When the core of these massive stars collapse, the release of gravitational potential energy can create a supernova explosion. Supernova is a stellar explosion that briefly outshines an entire galaxy, radiating as much energy as the Sun is expected to emit over its entire lifespan. They then fade from view over several weeks or months. All elements heavier than iron are fused inside supernovas. Following a supernova explosion, one of two things can happen. Either a neutron star is formed or a black hole. A neutron star is a type of stellar remnant that can result from the gravitational collapse of a supernova. Neutron stars are the densest and tiniest stars known to exist in the universe. Although having a radius of about 10 kilometers, they may have a mass of several times that of the Sun and spin hundreds of times every second. Black holes can also form at the end of a life of a very massive star. After a black hole is formed, it can continue to grow by absorbing mass from its surroundings. By absorbing other stars and merging with other black holes, supermassive black holes of millions of solar masses may form. There is general consensus that a supermassive black hole exists at the center of most galaxies. At the moment, we can't recreate nuclear fusion in a way that is energetically favorable, as in, we have to put in more energy than we get out. And so, with the current amount of research, it is not a viable alternative for fossil fuels, as we have to put in more energy than we actually get from the fusion.